Crazy Gamers Games, and we're doing an electronics video, and our special guest has returned, Kid Crazy.
Hi.
So how you doing today, Kid Crazy?
I'm doing very good.
All right, so we are working on another snap circuit. We're talking about battery packs in parallel. We're going to work on project 102. This is from, I'm not sure what set this is from. This is from the main snap circuit set.
Yes.
So this one comes with a student guide, and we're working through it this summer so we can get all the basics of electronics, because they're hidden inside these snap circuits.
Yep.
So basically we got some batteries in series. We got two 3-volt battery packs, a switch, a resistor, and what looks like two LEDs. So let's put up this. And why don't you go ahead and we'll move this over, and you go ahead and build that circuit right here in the camera.
Yeah, well, why don't we say what kind of batteries they are?
Oh, they're AA.
Okay.
They're each 1.5 volt.
Amazon.
Yeah, Amazon. Amazon is not a sponsor of this channel.
Nope.
They just sell remarkably cheap batteries.
Yeah, we just say.
So we're gonna put this on there. You wanna put the?
I didn't
Oh,
do that.
I got it. Sorry. So how do you do this? I already showed the batteries. So we have to put all the ones down in the circuit. I'll show you on here. All these ones with the ones. So we got the two batteries down. So now we're gonna need the resistor, which is 100 ohms. No.
This is a 2. Don't put it on.
Yeah. So we need the red diode or
Right
LED.
It looks like a white diode.
Okay. So make sure you got the positive because these are they have a polarity to them.
And it doesn't matter which side it is on. Just look toward the arrow.
Yeah, the electricity, conventional current is going to flow through it as the drawing shows. So go ahead. Now we're going to place the twos, which are the switch, the green LED, and two of the snap wires.
Yeah, the connectors. Now, it doesn't matter which way the number goes. That's your one. Make sure it's always off.
Yeah, make sure the switch is always off.
They have a big unveiling.
Okay, so let's see. Don't turn it on yet. I want to see how it looks on camera. Okay, so go ahead and turn. We'll go ahead and turn it on.
Alright, yeah.
So we'll see if we can't
That looks
zoom
white.
in. I don't know why it's jumping back and forth. Okay.
Still looks white.
Yeah, they're gonna look white. It's
Yeah.
just
Sorry.
This helps. Yeah, there we go. That helps a little bit.
Exactly.
So the two LEDs are on. Now the LEDs have a forward voltage of around 2 volts, which means they will take 2 volts to light up. And we're gonna we'll go ahead and bring a meter down here. AstroEye is a sponsor of this video, as is Snap Circuits. And we're going to go ahead and we're going to find out the voltage drop on this diode. So it's dropping about 2.8 volts, and the red diode is dropping 2.2 volts. And to figure out, the best way to figure out the current is, because Ohm's law is voltage equals current times resistance. So it's hard to measure the full resistance of the diodes, but we do have a resistor. So if we take a look at the voltage drop across this resistor, which is a clean 1.4 volts, if we divide that by the 100 ohm resistor, we will get a current rating. So let me just, so 1.4 volts divided by 100 ohms, and we get about 14 milliamps. Now, I mean, that's not, I mean, how do we know we're right? I mean, not everybody does math right, even though I used a calculator. Let's see how close we were. We're going to go ahead and test the current in the circuit. So to test current, as with the voltage, we measured parallel with each component. We measured across it. For series, for a current, you need to measure in series. So we're going to go ahead and turn this off, and we're going to pull this 2 snap off here.
Bye.
And then we're going to put a mirror. Wow, that just hooked right on there. Magnets are not all they're cracked up to be.
Yeah.
We're going to move this over there.
use metal around electronics.
We're gonna
They
try
may
this.
wipe it.
We may need the. Oh no, this isn't gonna work. So we may need the little test leads, but this might work. Yeah, this seems like it's gonna work. So I'm gonna set my meter to milliamps. If we have to switch it, we'll switch it, and I'm gonna turn it to milliamps. So
Snap.
as you can see there. So now we've broken the circuit, and then we reconnected the circuit with the meter. The meter is basically a direct short across the meter itself. There's what's called a current shunt, which is a large wire that is basically a short that generates that they can generate the current off of and read it with a microchip. So let's go ahead and we'll turn it on. And wow, look at that. 14 milliamps. So the math worked. Math works every time almost. As long as you input the problem correctly, then we know. So we have 14 milliamps running through this circuit, and that means the rating on LEDs is a maximum of 20 milliamps. So this is good. You always want to underrun LEDs, because anything over 20, they lose their life. So, well, that is it for batteries in series, lighting some LEDs, and that's going to be it for the snap circuit. Do you have any comments? What did you think of this experiment,
I
KidCrazy?
think it was nice.
You like that?
Yeah.
Oh, okay.
I also like these.
Oh yeah, little test leads. You know what? Just because we didn't measure it, let us measure the entire voltage across the batteries, because it should be 6 volts. Yeah, 6.45. So, and if you noticed, if you added up, the 1.4, the 2.2, and the 2.7, you're going to get that total. You're going to get that total back, because Kirchhoff's voltage law states all the voltage going in means it has to be dropped. It has to be expelled. It can be 0 volts coming back to the battery. So all that energy has to dissipate. Now the current states that all the current in a series circuit is going to be the same. Now if we do a parallel circuit, then that gets a little more complicated. That will be covered later on. But series, basically, you can take the resistance and divide it into the voltage drop across the resistor to get your current. And it's very important that you use the voltage drop on the resistance value that you are using for to do the math, because if you did the total voltage, that wouldn't work. If we did the 6 volts, we wouldn't have gotten the right number. So we had to use whatever the resistance was. We had to use the voltage that was on that resistance. Now, if there was a way we could do the total resistance of the entire circuit, then we could have used the main voltage to measure that. So that's going to be it for this video.
Oh, can I do the outro?
Go ahead.
This is Crazy Gamer and KidCrazy shining off. Bye.
Have a great day.